This demonstration is an example of how to do what I call a DERT problem, D equals RT. A DERT problem, or the book calls it, or a lot of books call a motion problem. Lots of ways to do these. I'm going to do just the way that I find pretty helpful, pretty simple, straightforward. Whenever I notice that it's going to be a DERT problem, I set up what I call my DERT box. And that's appropriate because we're talking about usually some kind of land or distance or something like that. And my DERT box has 6 compartments. Set it up just like that. It's much easier. And on the top, I put in the distance is equal to rate times time. That's a common formula that people need to know. Now, on the side, I want to put up my 2 situations that I'm going to be comparing, or the 2 different distance, rate, time equations that I'll be comparing. And usually it's designated by 2 different people. In this case, it's Will's Camaro and Jacob's motorcycle. So let's just go Will and Jacob. Now that I've pretty much set up my box, I need to fill in information into these 6 boxes. I usually look for something that's equal. For example, are the times equal? Are the rates equal? Are the distances equal? The reason I look for that is because unless I have a commonality between the 2 equations, there's no way of putting the 2 equations together. There's no way of making them equal if one of the aspects is not equal. So when I read this equation, when I read this situation rather, I say in the same time. So that's where it's equal. And I'm going to do a little sideways equal sign there. So now I don't have to worry about filling in those 2 boxes. I have to fill in these 4 boxes. So let's see what that means. Will's Camaro travels 15 miles per hour faster than Jacob's motorcycle. So x plus 15 for Will, x for Jacob. Because if that's Jacob's speed, Will is 15 more than that. I translate that as x plus 15. I also know that Will goes 156 miles to Jacob's 120 in the same amount of time. So 156 and 120. Now my boxes are all filled in. My DERT box is full, and I can go ahead and start working now on the equations. So let's see what I know here. If I look at just Will's equation, I know that time, because time is what's equal, so I'm going to say the time for Will is equal to the, divide both sides by r, I get the distance for Will over the rate for Will. Okay? I know that by, if I look over here, distance is equal to rate times time. I'm solving for time. Divide both sides by r, and I end up with d over r is equal to t. So that's what I did here. Now notice what else I did. I just put the time for Will, distance for Will, the rate for Will. So that's why I put those little sub names there. You can just put the initial if you wanted. I can do the same thing for Jacob. I know that the time for Jacob should be equal to the distance for Jacob over the rate for Jacob. Okay? Now let's start filling in some more things, because we can still do like a series of substitutions here. Do I know what the distance for Will is? I do. It's 156. Do I know what his rate is? I do that too. It's x plus 15 miles per hour. Let's do the same thing for Jacob. Do I know what his distance is? I do. It's 120. Do I know his rate? I know that as well. It's equal to x. Okay, so let's do some logic here. If the time for Will is equal to these numbers, the time for Jacob is equal to these numbers. But I do know that the time for each other, the time for Will is equal to the time for Jacob. I know that because it says in the same amount of time. What I'm going to do is a quick substitution, and I'm going to put the time for Will is equal to 156 over x plus 15. The time for Jacob is 120 over x. Now I have a rational equation, and what I can do is go ahead and solve that particular rational equation. Let's try that. Common denominator is x times x plus 15. So I'm going to put that in both sides. Multiply that by x over x. Multiply that by x plus 15 over x plus 15. Make sure you put everything in the correct parentheses. Since these two sides are the same, get rid of them. My second step, that gives me 156x is equal to 120 times x plus 15. Okay, getting closer. Now I get 156x is equal to 120x plus that times that, which is 1,800. Go ahead and subtract that, and I will get 36x is equal to 1,800. Let me get my calculator out and divide 1,800 by 36. And I get x is equal to 50. Fourth step, fifth step. Now if I go back to my original problem and plug in the x, I know that Jacob is going 50 miles per hour and Will is going 65 miles per hour. Jacob x 50 mph, Will x plus 15 is equal to 65 miles per hour. Now that's just one example of a DERT problem or a motion problem. There's lots of little twists you can do here. I'll go ahead and post other variations on this theme, but basically they all use the same DERT box. Always something has to be equal, and you should always set it up according to distance is equal to rate times time. And then you're going to have to do a series of logical substitutions. Okay? So just practice reading your problem. Don't go too quickly, and put things in the right spot. Okay, good luck.